Hey Chem Kids, Campbell here. In our first video on Chapter 12, we're going to talk about the states of matter and inter and intramolecular forces. So if you remember back to Chapter 13, we talked about kinetic molecular theory and how molecules are in constant random motion, and if the higher the temperature is, right, the more kinetic energy they have. And this applies to states of matter. All right, a solid, which is, real compact and it's not moving, the molecules will vibrate a little in the solid, but so they have the least energy and the least movement. We go to a liquid, right, now we have some more disorder in the system, they move around more, so we have a medium amount of energy and movement, and of course a gas has the most energy, right, it's all over the place. And if we think about any substance, as we increase its temperature, we're increasing the kinetic energy, and that's why they change from solid to liquid to gas, right? In the winter, water is ice outside when it's cold, and then it'll melt, and if it gets real hot, right, we get water vapor. It gets real humid in the summer here, and so we've got water vapor. Now, we need to talk a little bit about the properties of liquids and solids before we actually talk about some of the forces between them. And the first property is called vaporization. What vaporization is if we have a liquid and some of it evaporates and creates vapor, so it becomes a gas. That's called vaporization. And you need to know that because you need also to know the definition of vapor pressure. And what vapor pressure is once I've got these molecules above the liquid, I've got vapor above the liquid, it'll bounce, right, and exert pressure onto the surface of the liquid. So here we have an initial condition where I have water, and here's a U-tube with mercury in it, like a manometer. And if we start, this water starts to evaporate, right, I start getting water vapor, and that water vapor exerts a pressure. So notice that the line of mercury has gone down. So I've increased the pressure in the flask. And the more that happens, the more pressure it creates. And one of the things that will increase the vapor pressure is if we increase the temperature. If we increase the temperature, I've got more movement, more molecules can escape the liquid and join the vapor. Another thing you need to know is boiling point. Now, I know that you probably know that something is boiling when you start to see the bubbles forming in the liquid and coming to the surface, but you probably don't know what exactly a boiling point is. What a boiling point is, it's a temperature at which the vapor pressure, the pressure of the vapor, is equal to the atmospheric pressure. So when that happens, all the bubbles can rise up. And it always starts at the bottom, right, because that's the part where we're heating, when we're heating a substance, like a pot on a stove. Now, because atmospheric pressure varies with elevation, right, the higher we go, the less dense the air is, so it's going to have less pressure. That means that the boiling points actually change. So if you look at sea level, which is actually where most of us live here in Missouri, the boiling point of water is 100 degrees Celsius. Well, if we go to the top of Mount Everest, or maybe Mount Denali, because that's in the U.S. and Alaska, the boiling point actually drops to 79. So I don't have to heat it as high to make it boil. Of course, I expect that you know what melting point is, right? Melting point, here we are skating. Melting point is the temperature at which a solid goes to a liquid. So what determines at room temperature why some substances are solids, why some are liquids, and why some are gases? Well, the state of a substance depends upon the forces that are holding it together. Solids must have at room temperature must have a really strong force compared to liquids or even gases. Gases must have really weak forces. And there are two types of forces. There are intramolecular forces. Those are forces between atoms. Those are the chemical bonds. Those are inside the molecules. The other type are intermolecular forces. Inter is the force between molecules. So intra is the chemical bonds inside. Inter is between molecules. So you can kind of think about it like an introvert is someone who's really inside themselves, really quiet, keeps to themselves, where someone with good interpersonal skills is good with other people. So intra, inside, inter, outside. So there are 4 categories of intramolecular forces. Those are the chemical bonds between molecules. Now, in our last unit, we learned about 2 of them, and now we've got 4. So one of those is ionic. Ionic is when we have that metal bound to something else, like a polyatomic ion or a nonmetal. Those are, the electrostatic attraction between ions. There is metallic. These are new. These are just metals by themselves, like, say, gold. Covalent network substances, that's another type of chemical bond. It's very strong. And there's only 2 substances. There's diamond, super hard, and there's quartz. Then there's molecular covalent. Covalent bonds, remember we learned about in our last unit. That's when we have 2 nonmetals bound together. So our first element is a nonmetal. We have the polar and the nonpolar. Well, these are the 4 categories of chemical bonds, of intramolecular forces, forces between molecules. What's really interesting is these top 3 are always solids at room temperature. And again, we're going to talk more about that in class. What's interesting about covalent, though, is its state depends upon its intermolecular force. Inter, right, is between molecules. So for molecular covalent, the state of the substance, whether it's a solid, liquid, or gas, depends upon how big that molecule is, what temperature is, right? When it was really cold, we had ice, and then it got warm and it started to rain. And the intermolecular force, which you will see me abbreviate IMF. Intermolecular forces we're going to learn in class are hydrogen bonding, dipole-dipole, and dispersion forces. And hydrogen bonding, super, super strong. It's when we have hydrogen bound to something like oxygen, nitrogen, or fluorine. So, like I said, we'll talk about that more in class, but I want to talk a little bit more about the properties of liquids, because this is a lot of definition stuff and that's good for a video. So the properties of liquids are actually determined by their intermolecular forces. So all the things that we observe about liquids have to do with how strong they're bound together. Remember, hydrogen bonding is the strongest, then dipole-dipole, and then dispersion forces are the weakest. And so how strong they are will dictate how they behave. So the first thing I want to talk about is viscosity. Viscosity is the resistance of a liquid to flow. If you think about things flowing, like water doesn't, flows pretty easily, but something like honey, right? Honey, you have to like shake it and squeeze it to get the honey out of the bottle. So a strong IMF means higher viscosity. So that means the intermolecular forces in honey are much stronger than water. One way to get honey out of that bottle easier is to put it in the microwave and heat it up, because increasing temperature will decrease the viscosity. So let's take a look at the intermolecular forces. Here's honey. Honey's like sugar. And I have a bunch of hydrogen bonding in it. Look at all these hydrogens and oxygens, right? Hydrogen bonding, high hydrogen bonding in honey, which results in a very high viscosity. Water, which has, really great hydrogen bonding also, but it's a small molecule, right, has a relatively low viscosity. So stronger intermolecular forces, the more hydrogen bonds I have, the stronger, the higher the viscosity is going to be. But if I want to decrease viscosity, I will up the temperature. Surface tension is another property of liquids, and it results in beating of water or soap bubbles. And what it is, it's the measure of the inward pull by the inner particles due to what are called cohesive forces between molecules. So here is actually mercury. Mercury has really high intermolecular forces because they're metallic. And so these particles all pull on each other. They're all attracted to each other by these intermolecular forces. And the stronger they are, the more they bead and stay together. Water does that too, especially if you go get your car waxed. When you put water on it, it beats up real tight. Fluidity is the ability to flow and diffuse. So gases and liquids are both called fluids, so they all have a measure of fluidity. Cohesion, I just talked about cohesive forces on surface tension. Cohesion is the attraction to identical particles, so like the beating of water droplets, which is also like surface tension. Adhesion is the attraction to different substances. So here is, hey, do you recognize this? This is a burette, isn't it? or maybe it's a graduated cylinder. But we can see here's water, right? Water forms this meniscus, and you always are supposed to read the bottom of the meniscus, right? But that's because water adheres really well to other substances. So let's talk a little more about water. Water is really special. For a small molecule, it has some really unique properties. It has a high boiling point, 100 degrees Celsius. It has a high surface tension, right? It beads up, which means that it has high cohesive forces, but it also has very adhesive forces, right? The meniscus. So water is really special, and it's because of this hydrogen bonding. I mean, water's tiny, but compared to other tiny molecules, water is very different. And that's good because water is very important. All right, that's all for this video. Oh, I will see you in class.